So we can get started. Good afternoon. So how is the projects coming along? Making good progress. So how far are you guys to finishing up? You should set up a date for presentations. And would you prefer a class day, the last class day or something, or some other day when we don't have class, which would be easier? Including weekends is fine. The problem with the class day is that will restrict how much time each one will get. I would rather not do it in two different classes. I'd like to do it in one class. So you probably get like 15 minutes if it's in class. If not, you probably get like half an hour or so. It's always harder to give a shorter talk than a longer talk, right? Because you have to be fairly clear on what you're trying to say. So let me know. And the other thing is, if you want us to focus on some other topic that we haven't looked at so far, let me know too, because we can add those at the end. We're going to look at a little bit of storage after this, and then a little bit of security after that. But you can always add something else, right? So this is sort of the last one on the video sensor networks. And I think one of the nice things about this project is it talks about heterogeneous sensing, right? It talks about having multiple different classes of sensors and trying to coordinate between each one of them. And it's a implementation-based system. So essentially the idea here is to have multiple video cameras, each with a different fidelity, right? So you have like lower fidelity, meaning it's not as good quality as the higher one, which is good for something. So maybe it can detect motion. And then you have more complex cameras which can do more complex processing. So you want to have this hierarchy. Essentially, we're trying to do this for adding scale, for energy costs, and so on and so forth. So they actually show that the energy for running these heterogeneous systems can be lower than running all in a single tier, right? And there are many applications for video sensing in general, and this one also, which is wildlife monitoring. If you look at the habitat monitoring, here you can use it to look for rare species, observe like birds moving and so on and so forth. And ad hoc surveillance is one thing that a lot of people are excited about. Essentially, you have fire or something, you go in, put these sensors, and then you can see where the fire servicemen are going or what have you, right? And that is an interesting scenario, because one of the things people like to do is go into a fire, fire service people put these sensors, and then it does something with that, right? What do you think of such an application? Without thinking, I assume that you haven't thought about it too much, but for the fire service people to go in and put some surveillance. I know some of you, your group is working on similar kind of problems, right? How challenging would it be from what we studied? What can you do with sensing in that scenario? You can use whatever you use for. I guess three of you work on this same project, right? Team track, isn't that one of the stuff? So.
I'm not sure I understand the question. Sorry.
I'm trying to see so using Team Track or whatever you can think of, what do you think sensing can help in terms of like fire or emergency services in ad hoc fashion?
Well, in the case of Team Track, you could know the location of other responders.
Mm-hmm.
So you could know where everybody's at in relation to whatever the event is.
And how do you do that?
Well, the basic platform uses GPS. So if you're outside, so you can know where people are. We're currently working on ways of doing dead reckoning with the accelerometer and the compass, and that's worked. It's working pretty well.
So you have like a reference node which is outside the GPS, and then the other ones are based off of that using.
Starting with your last known good position, GPS or otherwise, and you can reckon from that.
So that application would help you know where the other responders are within the fire, right? So what else can you think you would want to do or can do with these things? Because one of the things that they would like to do is to be able to put these things so that they can watch the fire or watch some, run some algorithms to figure out something, right? Like survivors out there kind of stuff, right? Yeah, and some people are still very skeptical of this whole approach, right? Like the whole approach of going into a location which hasn't been mapped, you don't have an idea of where you want to go. It's a very important challenge, but we're still not there, and I'm not sure if this work is there yet, right? And watching exotic animals, I think the next two are the same. And baby monitor is one of the other applications people talk about. Being able to monitor your house and have multiple cameras, and you keep. So the idea is to keep something which you plug into a wall socket throughout your house, and all they monitor is movement. And if they see a movement, then they activate the larger cameras to monitor where the baby is moving around in the house. Right? I'm not sure how useful that application is because it's scary if you really don't know where your kid is inside the house and the kid is moving around the house. But it's an interesting application. So without going into the details of video, without going into details of water surveillance and all those things, the nice thing about the paper is they don't actually do sophisticated algorithms. They use very simple algorithms. So you have to be able to understand what would be done by each of the stuff. So three steps you want to do in all these things is to detect objects. You want to be able to detect something is happening, something interesting is happening from something non-interesting, right? So if you have a camera here, you may want to know whether a human being is walking around, whether a particular person is coming into the room, or what have you. But the idea here is to say there are times when there is no action, there's some times which are interesting, right? So that's the notion of detecting objects, right? They use a very simple algorithm here, which anyone can basically come up with, which essentially says that you have a camera here, you know what this room is without any human beings, right? And then that's the reference frame. And when people come in here, something changes, then you do a comparison between what you know as the stable one and what you know now. And if things change, then you assume that some event happened, something detected, right? So for that, you need to know what the room looks like without that event, right? So you need to first have a notion of this is the room without an event, and then you have to have notion of what happens when the event happens, right? That sounds fair enough, right? Do you think it's that easy? In this room, if you want to figure out, like, let's say we put a camera here, right? What would the room look like without any one of us here?
Well, philosophically, we can't know if we weren't here.
No, this is not philosophy, right? Like computer science perspective, what is your base frame you would want to use, right? Okay, there'll be a bunch of chairs, right? Let's assume the chairs are screwed to the floor so they don't move, because that makes it even more complicated, right? So you have a bunch of chairs which are kind of screwed into the ground. So would that give you a sense of the reference frame that you can use to figure out when there's people in the room? What about lighting?
You'd assume that the lights will be on when people are in the room.
Okay.
So you'd want it with the light. You'd want a picture of the chairs with the lights on for your reference.
So if you turn off the light, right, when you leave, would that be a event? With the approach they have, that would be an event, right? So you need to work through those kind of stuff, right? So in the case of a classroom, we can assume that the lights are always on, but in scenarios like wildlife monitoring and stuff, right? Light keeps changing all the time. So you're trying to figure out what's the base image for that particular time of the day, right? Outside, you have rain, fog, day, night, what have you. So you have to have a base to know what changed, but that base keeps changing with the time of the day, right? So you need to have more complicated algorithms, and that's what computer vision folks would give us, right? So the assumption here is they're not going to worry about it, but it's not as trivial as they make it look like. I mean, it's not. It might work for this classroom because you can assume that the light would be on, and you can have another case which says if the light is off, don't bother looking at this stuff. But in real systems, it may be more complicated. The next stuff is once you make this detection that something is going on, you want to detect, recognize objects, right? And that may be more useful for surveillance and all those things. Even in the case of wildlife stuff, you don't want to just know that there is somebody. You may want to know if there are students in the class or just people who are startling into the room, right? So you want to know if there's a classroom setting or not. So you have to run more algorithms to figure out, do this recognition. And for that recognition, you need better camera, better vision, right? So for example, in this room, to see if there is human beings or not, right? You could probably use a very cheap, the cheapest cell phone camera or what have you, because all you are trying to see is if there's human being there or not. But if you have to detect your face, you need more complicated stuff. You need to run more complicated algorithms because two of you may look same in the first step. In the second step, you're trying to figure out the difference, right? So you're trying to figure out more colors and stuff like that. And the last one is to track objects. The idea here would be you do the second step, right? The first step you detect there's something going on. Second step you detect something interesting is going on. And third step, you want to track the interesting object. So essentially you keep doing this. So if you think that the object is moving this way, you pass it along to the other sensors. So they keep doing step 2, but rather than all of them keep doing the step 2, you kind of say, I think the user is moving this way, so the sensor who's covering this area, you have to do this to keep recognizing if the user is here. So you're trying to track this user, right? So these are 3 different kinds of stuff that you could do. And as you can imagine, all of them require pretty complex calculations. All of them are pretty complicated because real life is pretty complicated, right? So if you want to do this within a fire scene and stuff, right, you have to have a basis of how the room looks like, what is to be worried about, what is not to be concerned, right? So a fire just breaking out may be an event that you don't really care for. So you need to develop algorithms which, for hopefully the computer vision folks would do that, right? The interesting part is you want to do this in a sensor setting, which means that all these algorithms have to come in from the more complex stuff into the sensor setting, right? So if you talk to the computer vision group, if you come to the department office, you see Professor Boyer and Flynn, capturing people and all those things, right? Essentially, you want to move them into these small platforms, and that's still a challenge. That's still an open question because they use fairly big clusters and servers for all their processing. You want to move it down, right? Once you get through all this stuff about vision and all those things, the surveillance and all those things, the next challenge you want to worry about is how do you do that, right? You can have one single tier where you set up one camera which can do all of these 3, right? Which means that this one camera needs to be able to detect objects, which you assume is fairly trivial because it's just detecting that something is going on. You need to be able to detect objects, which means that you need to be good enough to be able to recognize faces. So the camera has to be powerful enough to recognize those. And then the last one is be able to track the user. So it has to know where you're going, what's the next stuff and everything. Which means that your sensor platform would have to be fairly nice. It has to be fairly beefy. It has to be able to see all the stuff. It has to be able to do all the 3, right? So that approach, so that means you have to have this single tier of cameras which are fairly good. And they're going to be sitting there and doing even simple tasks like detecting objects using the high resolution camera, right? What they propose is to have this multi-tier architecture where you have first you have like very low fidelity cameras, which all they detect is whether there's light or whether there's motion, right? And then you have like more complicated cameras. So once the lower tier detects something is going on, right? So for example, in this room, you can have one which says whether there's light on or off. If there's no light, then assume there's no students in the classroom. So none of the other stuff happen, right? Once you detect this light, then you run the next level, which just looks for whether there's difference from the reference frame, whether there's objects. And once you detect the objects, then you wake up the other cameras which can recognize objects. So those cameras come online. So all those cameras do the recognition cameras are off all the time. They're just waiting for a trigger from the lower level to say, something interesting is happening, I'm detecting an object, you now do the recognition, right? And hopefully, when you do the recognition, and then when you notice a movement, you trigger the next high-level cameras to say, track this user, right? And that's their main goal. So to be able to have this multiple level of sensors and detect events. And that notion is more general than what they're doing for this video, right? You can imagine doing this for all kinds of sensors where you have high-resolution sensors, low-resolution sensors, and be able to mix some of those, right? Can you think of how you may apply this concept on some of the sensors that we looked at? For example, in the volcano net case, right? How would you use this concept in that scenario? Yeah.
If you had a few sensors that could detect small, like very high detail vibrations, then you could wake up a lot more sensors to, if you think there's a seismic event coming, to get location information.
So you're saying the opposite way, right? So you have few high resolution sensors, and they are the lowest tier, right? So they always monitor the system, and if they notice something, then they wake up the other lesser quality but larger number of sensors, right? Which is the opposite of what they're doing here. I mean, they assume that there's large number of low quality sensors and few high quality sensors. You're saying the opposite, right? Or is that what you said? Yeah. So it's like, imagine a whole bunch of these kinds of hierarchical systems, and I think a lot of people are trying to get a handle on those, because as you can imagine, the first tier of sensors it's either never powerful enough to do what you want to do, or too powerful for what you want to do, right? If you have only one class of sensors, then it's either too powerful or too less powerful. So you want to have this hierarchy, and how do you deal with that is an issue. And some of the benefits are cost and energy, because you assume that the higher powered one have more energy, and you kind of do a judicious mix, right? So they actually have a figure on their webpage. But I think from their paper, it has more tiers than what they have in the actual paper, right? In this illustration, they have a tier 1, which is this motion detection sensors, and then tier 2 is a camera, the CMU camera, which is very low energy, but not really good. And then the next tier is webcam, right, which is more powerful. You get a 640 by 480 kind of picture, and connected to a Stargate mode, right, which is more powerful, not necessarily as powerful. And then you also have a PTZ, pan, tilt, and zoom. So those cameras can zoom into wherever they have to go. They can pan, right? They can. So you might have seen those in security cameras and stuff, right? So these cameras can rotate around to see this room. They can zoom in, right? And yeah, they can tilt and pan, right? So the idea here is these cameras, if you have one of them here, and they detect some action going on here, then they can turn around and zoom into this location, right? And controlling that is hard, and those cameras are expensive and all those things. So so you have this hierarchy of cameras. But I think the actual system, they didn't have tier 1. It starts with tier 2, tier 3, and tier 4. So you have this multiple set of cameras, right? So some of the design principles that they use are the most interesting aspects of this work, right? The design principles are, if you want to do a task, you find the least tier that can do what you want achieved, and enable those, right? If your goal is to recognize objects, then find the lowest tier in the illustration you had before, right? Figure out which is the one that you can do the recognition, and enable those that would help you in recognizing, right? So recognition would likely need tier 3. That means you need to wake up the tier 3 cameras that could do the recognition for the image, right? If you wanted to do motion detection, then the lowest tier would be the tier 1. So wake up the tier 1 cameras which will do this stuff. So depending on what your task is, choose the ones which have the lowest hierarchy. The idea here is the higher the tier, they are more accurate, but more expensive, more energy expensive, dollar expensive and stuff, right? So this does not work if the cost were to decrease if you go this way, right? The idea here is if you go that way is cheaper. Tier 1 is cheaper than tier 4. Tier 1 is less energy consuming than tier 4. And tier 1 is less capable than tier 4. So the idea here is to use the lowest tier such that you can still get your job done. And then exploit the wake up cycle, which is one of the bread and butter of the energy conservation policies. The idea here is all of these things consume energy. Running a camera consumes energy, running a PC, running a sensor consumes energy. If you can put them to sleep, then you save energy because you assume that these devices have two different states. One is when they're operating, one is when they're sleeping. So exploit that, right? Exploit that by basically leaving the sensors which are not being used in the sleep state, only wake them up to do the task that you mentioned before. So if your task requires some sensors to be up, wake them up, otherwise let them continue to sleep, right? The challenge here is you would like to do that. You would like to put these things to sleep to conserve energy or conserve the resources. The challenge is the sensors don't wake up, the sensors need not wake up instantaneously, right? It may take some time. And I think in their setup, it took like 4 seconds to start up, right? So if you see if you need a camera to wake up, it took them 4 seconds to bring it online, right? They have to start the camera and bring it online. And that's a cost you have to pay, and that's something that you need to be aware of, right? So if you leave a camera on all the time, then it's ready to capture image whenever you want, but it's consuming battery all the time. But if you're willing to shut down the camera to bring it back online, it takes you some time, and in this case, it happens to be like 4 seconds. And depending on what the duration is, you have to be aware of this stuff, right? The problem, the manifestation of this problem would be if the lower sensor figures there's a motion in this room, right? It detects that something is happening. If it takes 4 seconds for the cameras to wake up, right? And suppose that there's a doorway this way, right? And suppose people can walk this way, right? If the sensor here detects that somebody coming into the room, if it takes 4 seconds for it to wake up, and the user can walk through this room in 3 seconds, right? That means the system is no use, right? Because essentially, the lower tier would detect there's some action, and it'll try to wake up the higher tiers. But by the time the higher tiers woke up, the events have gone past, and so the system would not be useful. And I think they face that in their setup, right? So you have to figure out what those different durations are. If they are too small, then you may have to keep waking up even though you would like to sleep, right? And the last one is more of a manifestation of what they can do. So if you have these cameras, if they can kind of overlap, then you can use that to figure out, make some estimation. If you know where this camera is, if you know two cameras are pointing in a certain direction, you can use that to make judgments on where they are, if there's overlap, right? So if you have two cameras here, and if they're both seeing somebody in the middle, based on the size, you can figure out where they are, right? And this is your elementary physics kind of stuff, right? So if you know there's a camera here, and you know that it's looking at this angle, and you know this camera which has another angle looking out, right? So if you, and the image is basically a projection of here, right? If you see somebody who's showing up on both image, you can figure out what this size is to figure out where the object should be, right? And so that's one of the nice things of having multiple cameras. You can use these to kind of localize where the people are because you know where things are, right? For this to work, you have to know where exactly the camera is. You have to know where precisely the camera is. If you don't know that, then you can't do this projection because you don't know how wide the camera is looking and where it's looking, right? you need to know this distance, right? And the location, right? So that's one thing that all these things require, right? Which is, if the lower tier figures that some action is happening, it has to wake up the upper tiers, right? It can do one of two things. One is it can wake up all the upper tiers and say, I notice some motion in this room. Everybody who's higher tier than me, who are watching this room, wake up and look at stuff, right? Which is wasteful. You don't want to do that. You don't want to be able to do that, because essentially it may so happen that each camera only say watches one of the chair, right? I don't want to be able to say, all of you wake up and look at the room, because there's only one action, right? So what you would like to do is be able to wake up just the right sensor, right? That means each sensor has to have a notion of where the other sensors are looking, right? So each sensor has to know what it's looking, right? It has to know wherever it is looking, what other sensors have coverage in the same area. That means all of these cameras have to be calibrated accurately, right? So if I'm a camera and I'm looking along these lines, right? And if I have to wake up like these three to say, you should look up more carefully because I can see the stuff. So I need to have a notion of where they are looking, and they need to have a notion of, they cannot change what they're doing, right? Because if they tell me, it does not work, right? Does that make sense? Right? So if I'm looking this way, and I know that he's also looking this way, then I can say, I can't really see clearly, you need to look up, right? But if somebody changed the camera to look somewhere else, then this whole system fails, because the lowest tier thinks that upper tier has to wake up. If the upper tier cannot see it, either because it's misaligned or the event has passed by, then the whole system fails. Then they have to go into the failure mode, right? So how serious of a concern is that? Being able to know not just where you're looking, but being able to know where everyone else is looking, so you can kind of figure out. So it has to be fully calibrated, right? The system, for this to work, you need to have cameras. You put the camera here, you have to localize where it is, you have to figure out where it's looking, and you have to do that for each other camera, which every other camera knows, right? So if you change something, if you go into the room and change something, then this whole system will fall apart, right? Because the lower tier would say, I'm looking at something, you wake up and look at it, and the camera somebody changed, so you cannot see anything, so it's waking up and it's wasting energy, and you're not, the whole system falls apart, right? How serious would that be? Going back to the application they talked about, right? For the outdoor case, looking at animals and that stuff, how would you deploy this in the outdoor scenario for looking at wildlife and stuff, right? Yeah.
Seems almost impossible. If animals, if you don't know the distance, you wouldn't know the size of the animals and things like that.
But so you don't need no size of distance of the animal. You just need the distance between these cameras, right?
You just want general motion and things. You could do that, but you would.
So how difficult would it be to know this distance and this, like where they're looking?
It would seem fairly complicated. You have trees.
So it depends on whether you artificially make. You put them on poles or something you put out there yourself, you could know the distance pretty easily. You're working with trees.
So can you put it in a pole?
You get it relatively close then.
Do you think you can put it in a pole?
You run into all the problems we talked about before with like birds laying on the pole and all that kind of stuff.
But other than those issues, right? There's this issue of birds and actually birds and bees too, because they can build nests and stuff, right? The other problem is you don't want them in the middle of animals moving around and toppling it and all those things, right? So assume that those issues are kind of worked out, right? Or we ignore it or what have you. Is this feasible in that setting? So you also want something where the view is good, right? So obviously if you have like a whole bunch of trees right here, right? you may not want to put a camera right here. So you need to find some place where you can reasonably see. I mean, all these things require you to see something, right? So the challenge is, can you reasonably do it? Can you reasonably do it such that these sensors, you know precisely where they're looking and how far apart they are? Because everything you do depends on that, right? If you move this later to somewhere else, you have to tell all the sensors, because now they have to know who, how they overlap and all those things, right? So now can you do that for ad hoc surveillance setup that they talked about, right? Ad hoc surveillance, I'm assuming like fighting fires or watching a football game or something, right? Like looking at the crowd in a football game or what have you. Let's look at the fire case, right? Can you use this to do some ad hoc deployment?
It's very time-consuming to deploy it just because of that.
Mm-hmm.
So if there's some sort of response situation where there's a timeliness factor, no. Probably by the time you set it up, whatever event you're responding to would be over.
Mm-hmm.
I'm not sure that every node really needs to know the orientation of every other, just because, you're just going to do a handoff to your neighbor.
Mm-hmm.
So I think as long as you know the orientation of those in the vicinity,
Mm-hmm.
then that's probably good enough.
So your assumption, okay, if you assume that these are like this, right? Like this node knows it has to hand off here, kind of stuff, right? So if there's error added here, right, then this might fail. This handoff may fail because it's now no longer forwarding to the right node, right? So the idea here is if you're going this way, right, and if this camera had moved, then this won't be able to hand off to this one because now it's misaligned. But these things may work, continue to work, right? Is that the verdict, right? It's pretty challenging. I don't think there's a easy answer to this one, right? And some of the folks were saying, one of the meetings I was in like a week or so back, that they cannot imagine how you can do this from in the fire case or what have you, right? Because essentially you have to go inside and say, fire, stop, let me instrument this whole place, right? And then go kind of stuff, right? It does not really work. So you really like this to be on the fly, and then it becomes way more complicated, right? So if you don't have any notion of where these cameras are looking at, then it becomes much more complicated. Especially if you have like a zoom cameras, then essentially when you zoom, the angle changes. So when you're zooming, it essentially becomes the angle narrows, right? So if you let each camera decide where they zoom and where they turn, right, then being able to hand off these things become much more harder, right? So is that a problem just with the hierarchical stuff, or would that be a problem even without hierarchy? Without going to details into the vision part of it, right?
It seems like it would be a problem for both.
Mm-hmm.
Especially if you allow your cameras to pan and zoom, and there's only pan and zoom cameras, you still have that problem.
Mm-hmm. But I think at least the hope there is each camera can at least do something, right? So it may so happen that if everybody is capable, right? So I can at least say I saw somebody with a blue shirt, right? I saw like this bad person with a blue shirt. I can at least do my detection. So I won't be able to hand off to anybody because now we have no clue where we are all looking. So I may not be able to tell others, and nobody may be able to catch on to what I saw, right? But at least I would be able to do what I have to do, because in a single tier, each of the elements you expect it to be able to do some processing on its own, right? In a multiple tier, the lowest tier may not know enough to actually make any conclusion, right? Depending on the task you're trying to do. If you're trying to do motion, yes, that works fine. But if you're trying to do detection, the lowest tier, all it knows is motion. So it knows there's motion, right? So you never escalate beyond that, right? If you don't tell the right set of sensors to wake up and look at the stuff, then all you come up with, there's a motion, but you have no idea what
You'd
happened.
still be better if you just turn, when you detect motion, turn on all of the higher level ones, and then when they detect something, you still do better than if you just have all highest level all the time.
Yeah, that's an excellent observation. Yeah, you can. Yeah, so you can degenerate to a case where you wake up everyone, right? At least in this room, and say, all of you wake up because I have no way of looking at this stuff, right? But it's still it's a lot of challenge, and people are working on how you can manage this, and the technology to do this is very hard, and there's a lot of applications for doing this stuff, right? So this is similar to a problem of trying to stitch together all the pictures that people took of, let's say, landmarks like Golden Gate Park, right? I think there's like a reason somebody was trying to do this in the thing, right? Like you want to look at all the pictures people have taken Golden Gate Park, say from Flickr or one of those sites. How do you stitch them all into figuring out what this one big picture was, right? That's essentially, that's more like a fun project, but essentially the same as this one, right? So there's a lot of research going on in that direction, and people have made some progress, but not enough, right? From the entertainment perspective, like one of the things that they would like to do is when you take a picture and put it into Flickr, if Flickr can automatically add picture in front of Golden Gate or something, right? So it kind of learns based on where your camera angle is, what you see, to figure out what are the landmarks in the back, right? That would be a really awesome tool for all these sites, right? Like Google and all those things. So they're working really hard at that. Yeah.
Have you seen what Microsoft's done on that?
No.
Yeah, they have, there's some website that they have set up from one of their research groups where they did something almost exactly like that. It was,
They got 3D with
Cathedral somewhere, I forget exactly where it was, but they created a 3D tour of it based on just thousands and thousands.
Yeah, there's a paper on computer vision this year on doing that, right? Like using, there's Notre Dame Chapel, the Paris one, and few of those based on pictures, right? It's been a hot area within multimedia community for a long time. How do you annotate based on what you see, right? And it's a lot harder than what you imagine because you don't. So essentially, you don't know what the camera stuff is. You don't know what the angle is looking at, right? So depending on the angle, if this is physics or what have you, right? The object may look smaller or bigger. I mean, the projection changes based on your point of view and the camera, right? So if you have a pyramid here and you're watching from here, and your camera's, this is the angle of view, and there's another camera here with angle of view here, right? So you have to map. So you don't know what this is. You don't know what this is. You don't know what this is. You don't know what this is, right? All you have is this projection and this projection, and this projection, like two pictures. How do you go back to figure out where they were looking at and get information to build this pyramid, right? I've seen research projects since like 2001 trying to do this stuff, trying to figure out where this happens and stuff. So if you use like Facebook, you can actually say in the picture, if you have a human being here, you can say this is like, blah or something, right? They would really, 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 really love to say, oh, by the way, this is the, pyramid in, Giza, something that they can automatically detect and say that stuff, right? So regardless of why they want to do that, it's good because essentially they're developing the technology to make some of these things easier. If you can do this, obviously the research being done it's not constrained by resources. I mean, they don't really care about how much computers they can use. They want to be able to solve the problem. But eventually maybe it'll come into the sensor world, but then I can put these sensors, I don't have to say exactly where they're looking, then they can kind of learn from the pictures what angle and so on and so forth. Right now it's very fragile. Right now it's, if you move these things, then you have to go through extensive experiments on how to do that. And for that reason, I think all their evaluations were based on projecting circles on a screen. Right? If you look at the experimental setup, right? all of them were watching a blank screen, and the projector was projecting a circle, and the circle moves, right? So there is no depth because it's all the same depth, and it's a little bit easier to look at that rather than if you have people who are moving and so on and so forth. Yeah, so there's a lot of interesting stuff that can be done because essentially you need to do the stuff and then you need to move that from the servers into these little modes, right? So it's not clear to me what you can do right now. I mean, obviously if you have all the technology, it's good, but right now, what can you do remains to be seen. But essentially, these are the big challenges, and I was kind of surprised that they didn't give too much importance on the localization problem, right? Because it's a lot worse than localization as we talk about it in general sensors. I not only need to know where precisely you are, I precisely need to know how far I am from the ground. I precisely have to know what camera angle I'm using, because it's not just me being here. I need to know I can only see here, right? So you, like somebody over here, can decide what I'm seeing and see if they're matching, right? And this may happen for this. This may happen. So would this happen for the volcano scenario? This need for the one that Nate was talking about, right? So let's assume we have these high powered. Let's see. The big circles are the high quality ones. Right? So you're assuming that these detect something and they want to fire the others, right? So in that scenario, what would you want to fire? Like if this one detects some action, right? What would it turn on? Which sensors do you think will turn it on? In the case of the camera network, you have to say this camera was looking this way. That means only cameras which are along this path would have to be woken up, right? But in the case of volcano stuff, what would you turn on? Yeah.
It seems in their example you turn on everything, but I mean, I guess if you wanted to verify that the sensor was actually a valid event, you could just turn on the local circle. But it seems if you wanted geographic information, you would just wake up everything.
Everything, you mean, like this one too?
Right. Or like thought there was an earthquake, coming, you would just wake up everything.
So if you do that, right, then you don't need to know where the sensors are. You just wake up the whole world, right? Can you optimize on that one? Can you figure out which ones you would wake up? Let's assume that these are localized, right? Let's assume that the earthquakes are kind of geographic, right? I don't know if that is true. I mean, but let's assume it's true, right? So what would you wake up? So these ones are the powerful ones, right? And this one is sensing something, right?
Probably, if you want to optimize, you wake up the local ones, see if it's more powerful towards a certain side, then continue waking up local ones. Like, so first off, you only have 1 point, so you want to wake up everything all the way around.
Okay. Yeah.
At that point, you've got a bunch of different readings. You coordinate somehow, figure out if one side has a stronger reading.
Yeah, like let's say this is stronger.
Sensing along that direction.
Yeah, you do something like this.
Right.
Yeah, you would do something along those lines, right? And people have been thinking about how this would happen too, right? From a computer science perspective, these are essentially Warnock diagrams, right? You essentially have to figure out. So the problem is, if this one did not detect, then you have to at some point say, there's nothing being seen here, there's something being seen here. So essentially you would develop a Warnock diagram to figure out which is on this side, which is on that side. But from a practical perspective, Bonner diagram computation is so complicated. You would basically do something like this. You basically start to propagate these. So can you think of reason why this is bad compared to waking everything up and then seeing, and then letting each of them turn off if they don't notice anything? Under what circumstance would this be not preferable? Basically, you're kind of like going as a wave, right? So you're kind of like starting all this stuff, and then they all start this stuff and keep going, and you get all the stuff, right? Yeah. Yeah.
What could be the delay involved in, say, if the object is moving and you could miss it just because?
Yeah, I mean, that's one of the things which all these things require, right? You have a competing goal. One is all these things have to be asleep, right? If they're sleeping, that means they're not listening, right? That means they're not doing anything, right? So you can't really make them, you can't instantaneously say, I'm detecting something, you also detect, you also start, unless we are always in communication, right? If there's a communication link between these all the time, then it can say, I'm noticing something, immediately turn yourself on. But in that case, you don't have any savings. So what you end up doing is you have to have these things sleep and wake up every so often, which means that when you detect something, you can't really tell somebody till the next cycle, right? Till whenever that is, right? If it is too long, then it's useless. If it's like, for example, a day, that means this one says I'm detecting a seismic event, right? But it'll take me up to a day to wake up everybody else. Not good, right? If it is too small, then essentially, if it's like a millisecond, that means the link is always on, all the battery will run down. So you have to have this balance. So whatever balance you have, it takes a while to wake these up. But if you have to go into these motions, the seismic event might have stopped before you wake up the right people, right? So depending on the application, you'll have to figure out which one do you want to do, right? Yeah.
So it depends on how much error you have in your sensor measurements, because if you say you have the lowest tier sensors and they're subject to a little bit of error, every time there's a false positive, you wake up every other node in the system. Well, then, depending on how you characterize your errors and so on, your whole system may be on more often than it's off. So
I mean, the concern he has applies here too, right? It all depends on how much noise the lowest tier gives, right? And I think example is this accelerometer, right? It kept detecting something for a while, right? If the lowest tier is very highly sensitive and is crying foul all the time, all the upper tier are always up. If the lowest tier is not very sensitive, then you may miss all those, like a lot of interesting stuff, right? So for example, if you're moving very slowly, right? If the lower tier expects you to move at a certain pace and you're walking like a snail goes by or something, right? If the threshold is really low, then the lowest tier, if it cannot detect it, the whole system cannot detect it, right? So even if in the case of the system where the higher tiers could have detected it if they're woken up, wouldn't have happened because the lowest tier is the gatekeeper, right? So you want the gatekeeper to be just sensitive enough, even though by definition they are not as good, right? To be waking up at the right instance, right? They're not too sensitive, in which case the whole system breaks down, and they're not too insensitive, in which case you don't detect any of the events, right? And that is fundamentally a hard problem to do, right? Because in the camera case, you expect the highest tier cameras to be sensitive enough to know precisely what is real and what is not real, right? But you don't expect the lower tiers to know those stuff. Actually, we can look at the little bit of the hardware, right? In the case, the tier 1, they use two kinds of cameras, the CMU cam and the Cyclops, right? And each of them have a different times it takes to wake up the camera and different energy levels, right? And different power levels and stuff. We don't need to know the details of what they are, but these are lower powered. And the next level is a webcam. Again, you may not be able to see all the stuff. They have a think of how much each of the operation takes, waking up and starting the camera and all those things. And you can see that, right? If you have a camera, if you turn on this camera, right, it does not immediately take pictures. It takes like a little bit while it's tracing all those things, and that's essentially the time it takes. So it takes about 4 seconds to start up, right? So that constrains what you do, and then you have the pan, tilt, and zoom camera connected to a mini ITX, right? So I'm not sure why this camera was added, because I don't think they talk about it too much. I think it was added basically to say, if none of the cameras see something, then you can use this pan, tilt, and zoom to look out, right? So if suddenly something detects something and nobody else actually saw it, then you can use this to zoom into the stuff, right? Because to me, if you add this one, you don't need anything else, right? Because this one doesn't look like it's going to be on battery. I don't think you will put this on battery, because this is running on a regular Linux machine and what have you, right? So it seems like that could be on all the time, could be doing all the detection and all those things, right? So let's assume, for argument's sake, that you will want to turn it off and then only zoom into the areas when there's action, right? And of course, the graphs they have, so if you use the single tier, you probably cannot see it, but the single tier, it takes like about 1500 joules. But if you do this multiple tier, it's pretty good. I mean, I think it's about 136, depending on if it's a Stargate based or modes, is like about 9 joules, right? So you have lots of savings, right? But all of them assume that you are able to filter out the interesting events at the lower tier, right? And in the experiment setup, it all worked out that way, right? But in real life, it's a big challenge, right? The system is so fragile because it depends on the accuracy of the lowest tier, which is also the most incapable, also the one that actually doesn't know what's going on. You would want it to wake up the higher tiers, but you don't want to wake it up too much. So I'm not sure what the balance would be. I mean, if you do this on a real system, so like for example, if you do it on the wildlife stuff, right, you'll have to tune it. You have to say what is acceptable and what is not acceptable, right? So assume that you are the ones who deployed it in the wildlife setting, right? And you're looking for some animal, right? Like let's say rats. You're looking for a rat, right? What are the kinds of stuff that can trigger your camera? You have the multiple tier, right? There's one which is looking for motion, right? Can you think of some things which can trigger your camera other than rats? Assume there are no other animals, right? Just the only animal in the world is rat. That's what you're observing, right? What other stuff can trigger these motion things?
Leaves blowing through the camera's field.
Yeah, leaves would be annoying, right? Because leaves look like rats at that level, right? Assume that these are big leaves, right? So you have leaves flowing, right? So how would you program the lowest tier to differentiate between leaves and mouse?
I don't think you can. Lowest tier being just a motion sensor, right?
Motion sensor or the little camera, like the Cyclops or something, which obviously doesn't seem like it's a very good camera, right? Yeah.
It depends on what kind of motion sensor it was.
Mm-hmm.
I mean, some seem to, and you can program them to detect various
Mm-hmm.
percentages of the field of view. And it's like sonic, you know, do something with density of objects.
Mm-hmm. But yeah, the least I think you'll have to, it'll be a trial and error kind of mechanism, right? You have to figure out what are the environmental stuff that happen in this particular area which need not be recognized, right? Yeah, eventually I think you'll come to a point where the first tier is good enough to recognize whether it's the mouse or nothing else. Until you get to that point, leaves or snow or what have you will keep triggering these things, and that would be a hard problem, right? We actually had this discussion like a couple of weeks back in one of the program committee meeting, right? there are a lot of projects which are like being done, which are very fragile, like what this paper was nominated for the Best Paper Award. So this is considered to be a very good work. But some of the challenges are fundamental to this whole system, right? You are expecting these lower level tiers to be highly energy efficient and not resourceful, but you also expect them to be fairly accurate because their inaccuracy affects the whole system, right? And so they have to be accurate in terms of what they detect. They have to be fully localized to know which ones they can wake up. Because if they have to get to a point where they wake up everybody else, then you save some energy, but I'm not sure how much energy you save. And you also have to account for the time it takes to wake up your neighbors. And that's a harder part. So the goal is like they don't claim that they invented a new algorithm, right? Even though I think that there's a need for moving some of these algorithms from the computer vision or recognition community to these sensors, right? Because vision community, they talk about servers and clusters and stuff, but you want to move it somehow into these sensors. How many of you have seen a webcam which can do motion detection, right? Like most of the stuff, including the ones in my office, can do motion detection, right? They can figure out when I'm in the office, detect my motion, and then trigger something, right?
I've seen security cameras.
Security cameras where?
Like stationary security cameras.
But most of them tend to be awfully poor. Like the ones in my office is awfully poor, right? Like if you have a higher processing, so essentially those cameras are always on. If they detect something, they kind of zoom in, but they're always on, they're always processing, right? But if you want it to sleep when it's not on kind of mode, then they're awful, right? So we need a lot of help from the vision community to approach this. So the meta question is, for this scenario, right? If you were in charge of this scenario, would you use one tier 3 camera, right, which is running the PTZ with the Linux mini PC, or many of these other ones? Why? Maybe not one, maybe like a few tier 3 cameras, or a whole bunch of these tier 1, 2, and 3. Yeah?
I'd say the tier 3.
Tier 3?
Because especially with these animals or security monitoring, the person may be gone in 1 second it takes to get the system working, not to mention the processing time to determine if you wake up other devices. So it seems that you want the data. You don't want to say, oh, something happened, but we don't have any video of it.
Is there any dissent? Yeah.
It still seems like, it depends. I mean, if you're able to plug in the PTZ camera and have it not run off battery, then yeah, you're probably better off to just do it that way. What's the point of having all these other battery-powered ones? But it seems to me like in their paper that they were assuming that the last one was still on some sort of battery power, and it would just be activated so rarely that it would conserve the power that way. And that's the case where you want to use.
Yeah, but I think PTC cameras, if you want to turn it on, it takes a lot longer than the other ones. It goes through calibration itself to figure out how far it can go. It takes like minutes for it to start up. Because you can't just, most of the cameras expect to be on all the time. So when they wake up, they go through the cycle of like, they go 360 degree this way, they go back and forth trying to figure out, where they can.
Need to reprogram it then to skip that stuff. Maybe just say the state of where you were last pointing into some registers and say, wake up, check these registers.
Yeah.
Figure out where you were last pointing.
So the other idea is like, how would it be if you have that one camera, high quality camera, and set it up as a really wide angle, right? Essentially, it can see this whole room, but not in enough detail to do anything else the zoom camera can do, right? So assume that it can see this whole room like a fisheye kind of stuff, right? And it's monitoring the whole room. It can't do the detection, so you still have a hierarchy, right? Of one PTC's kind of seeing the whole room, and then another one kind of zoom in and do this analysis, right? Would that be a better way to go than having these lower fidelity motion cameras and stuff? I don't know what the answer is. But yeah, but there's a lot of this kind of a hierarchical setup, and this is one of the good examples of a hierarchical setup, right? And it doesn't sound all that interesting if you're talking about temperature kind of stuff, because you don't need a hierarchy. You can have the each one be able to do this processing. But in terms of video and stuff, it's a lot more interesting. I think it's a lot more easier if this is audio than it's video, because audio, the microphone picks up as a circle rather than this video where it only sees in a certain direction, right? There's also some work being done which can look out on 360-degree angle, right? But then the recognition algorithms become much more weaker, right? Sort of imagine how the Google what do they call it, the city view, right? What do they call it? When they go through the city and get all the street maps, right? Street view, right? They don't want a camera which is pointing at, which is making, it's taking a picture of all the whole scene all at once, right? And maybe go from that one. But so does Team Track do something like this, like coordinate, like have hierarchy of sensors, or?
Pretty much
Flat, okay. Yeah, I think the localization on this system, I have no idea how you would do that. Right? Theoretically, it seems possible. You can figure out exactly where they are, but practically, it has to be so precisely aligned, because any or you have to go through configuration stuff where you walk around and basically, so you need to know what each camera sees, right? What it can see, what it cannot see, and where the overlap is, right? So you need to figure out that setup, and that's not trivial at all. Even if you see what the vision group goes through, right? You guys probably seen the people, like, they take pictures and all those things, right? When you walk up and stuff, and you have those little stickers where you're supposed to stand. You can't just randomly stand somewhere, because they want you to stand exactly where they are. The camera's exactly at a certain spot and everything to get the sense, right? You are doing the exactly same thing, except there they can take like an hour to set up for you to stand at one place and do the stuff. In real life, I would want you to sit wherever you want and be able to detect you, right? And that's way much harder. But I still think it's a interesting problem, interesting challenge. I just don't think that we know how to solve many of the issues involved, right? So did you guys read this paper? I think it's a good paper. So we'll read a few papers from this group. Some of these folks have been doing this stuff for a while. So we'll look at some of the storage work by some of the same authors along these lines. And the idea here is to, if I can store stuff, then I may be able to kind of go back and look at the stuff, right? Rather than being all real time. If I can have some kind of a storage, then maybe I can use that to figure out what happened, right? So the sensors can wake up, capture something, store it, then I can kind of go back and look at what those contents are, is where they're going. So we can look at that on Thursday, right? So on Thursday, I'll give the homework assignment, which I think is due like 2 weeks or so. And like I said, send me email if you have any topics that you'd like for us to cover. I'll send an email reminder too. And if you run into any problem with your projects, let me know. If there's something we can meet on Thursday. In Notre Dame, it seems so trivial, right? But scaling beyond certain things does not even seem to make sense, right? Why would you want to know the temperature across the whole planet. I don't have a background in like